Welcome to Study Loop.
Okay, so our problem is a projectile problem. So we have this projectile on Earth, and we want to see how high would go on the moon if we know the differences in the accelerations. So first, with our Earth part of the problem, we want to figure out what that initial vertical velocity was, because that initial vertical velocity will dictate the vertical velocity on the moon, since those initial conditions are going to remain the same. So we can start off using this kinematic equation of Vf squared equals Vi squared plus 2a delta y. And then if we think about a parabola of our projectile, at that maximum height, that Vf squared is going to be 0. So we can rewrite our equation with our knowns. So 0 equals Vi squared, what we're solving for, plus 2 times our acceleration. Now our acceleration in the vertical direction on Earth is going to be gravity, which is negative 9.8. And then our delta y is going to be the 60 meters that they told was our maximum height. So using this, we can solve for an initial vertical velocity, which comes out to be 34.3 meters per second. So this is on Earth. So now we want to go to the moon. So we can use the exact same equation, but for our moon. So we'll do Vf squared equals Vi squared plus 2a delta y. In this case, our Vf squared is still 0, but we know this Vi squared, we know a, we just are solving for y. So now we can say 0 equals 34.3 squared plus 2 times our acceleration. Now our acceleration in this case is going to be 0.165 times negative 9.8, because they said that the moon has 0.165 times Earth's gravity. And this will be multiplied by delta y. So now when we solve this for delta y, we find out that delta y is equal to 363.8 meters. So this is our height for the moon. This is our final answer, so we'll circle it, and if we do a brief sanity check, we can see that in this equation, the only difference, right, is going to be this a that's going to affect this y. Our a from the moon is around 1/10 of Earth, so it makes sense, right, that our delta y would be 10 times bigger than Earth. So that is our problem.